center of our overall work. So just a quick overview. These are just very briefly on what's new in Packet Tracer 8 in just a couple slides. First of all, of course, physical mode, in which we will be talking about mostly by the end of this session or in the second half of this session. These physical mode enhancements include shelf to store equipment and pegboard on the wall to store devices and cables. Then experience to move equipment from the shelf to the rack or on the table. Cabling to the port. So now our students need to select appropriate cables and connect devices using their proper ports. Front and rear view on devices is supported. Also dangling cables. This is probably the most visual component. And management of the cables. Apart from just the rack mount or wire enclosed experience, there are some other very important updates in PT8. First of all, it is the color grid for wireless display. So now wireless networks are displayed in a much better way. There is also a new updated and enhanced activity instructions window, which is way better structured. Also, network controller and PTNA. This functionality of PTNA now came into the general release of Packet Tracer, and while it was even before available in the special version of Packet Tracer inside the DevNet Associate VM, now it is available in the general Packet Tracer with some enhancements. Right, so these are just kind of briefly what's there, and let's start from the beginning and kind of most obvious things which changed in PT8. We have a new set of splash screens. Instead of just one picture when the application starts, which used to be always the same, now we have a set of splash screens which vary from one application launch to another, and so far I've seen 6 of them. I'm not sure, maybe I would assume they are random, and I may be missing just some, but I've seen 6 of them launching Packet Tracer many times, and these definitely help to promote some rich Packet Tracer functions, including network simulation, physical mode and reckon experience, network controller and programmable APIs, simulation mode with the tracking packets, multi-user mode, which can bring different Packet Tracer users together while they are even physically separated, and of course IoT device simulation. This is absolutely great. I think it's a super good idea to include these splash screens because they help to really show people that Packet Tracer is not about A, right? And this A could be anything. This could be some feature of Packet Tracer some people really focused on. Most of the people, I would assume, they are just focused on the network simulation. But I know people who really think mostly Packet Tracer is a tool for IoT simulation. They really start Packet Tracer and they start doing creating IoT devices there. So there are many different use cases. Moving on to the activity instructions. The new activity instructions window. First of all, it is a dockable window right now, which means that this window can be placed inside the main window of Packet Tracer, or can be taken outside of the main window and be kind of a hovering window on the top. Layout of the new activity instructions window allows for multiple instruction pages built into tabs. So instead of kind of switching from one page to another, it can be set, the activity can be set to present each page in a separate tab, right, in a separate panel, like it's shown here. This way it can be used to split different parts of the instructions document, such as topology diagram, addressing table, and textual instructions into separate panels, and make these panels visible to the user, to the student at the same time. It is possible to select horizontal or vertical layout to best fit content. It is possible to group pages into tabs, like it's shown on this screenshot on the right side. It also supports independent zoom and scroll in each of these panels, which is absolutely great. So you can make a comfortable zoom on your topology At the same time, you can look at a specific place or the specific row in your addressing table, and you may be at a specific step in the instructions, and all at the same time on the same screen. Right? This is definitely way more convenient than just scrolling a single PDF back and forth between addressing table and textual instructions. And as I said, this window still can be undocked and used in a standalone window on maybe put on the second screen or something like that. Furthermore, there are some enhancements, of course, in the back end of the activity wizard, because these instructions, they are written there in the activity wizard by the activity author. First of all, our activity authors definitely will like the new rich text editor. To write the instructions, you now have this new rich editor tab over here, and using this tab, you can really just edit rich text. Before it was available, you had to edit a little bit of HTML here and then just preview it. Now pages can be set to show as tabs using this checkbox over here, show pages as tabs, and then you see it will treat each page of the instructions as a separate tab or separate panel. Pagination or paging in instructions were available even long time ago, right? So on this specific screenshot, you see we are currently looking at page 3 out of 3, and we can use and always could use these buttons to kind of navigate through the pages. And the primary function of these pages was the idea was that we have like instructions split into big steps, big parts, right? So, and one part per page. So you complete instructions on one page, you click next page, being a student, right? And then you move on with the instructions. I don't think it was really popular. I've seen it being used in some of the labs, but not too much. And with this enhancement, the idea is really, okay, let's say these pages are not really pages to list through, but these are just pieces of content to be displayed to the learner at the same time in different panels, okay? And that's the idea. So that's why we have also the tab name here. And basically this page number 3 will be displayed to the learner as the tasks panel or tasks tab. Yeah, and this way you just have 3 pages, page 1 for topology, page 2 for addressing map, and page 3 for textual instructions. You can also set change between horizontal and vertical layout, whatever fits best. I couldn't find a specific use case when vertical layout is helpful, but there might be some. And also another exciting feature, user nodes. So user nodes can be enabled over here in this switch box. If the option to show user node is selected, then in this activity window for students, the additional tab is available, which is user nodes, and in these nodes, the learner can write any kind of notes, right? When they save this PKA file, these notes are saved within the file, and obviously when instructor opens this file to check the work, they will see the notes as well. I can imagine just from top of my mind a couple use cases for that. First of all, when students encounter some like challenges with the lab, they can just note it for their instructor. Or maybe another case is when instructor may want specifically ask some questions in the textual instructions and require or request students to provide some answers in the notes. That makes sense, right? And also these notes, they can be kind of pre-written by the instructor. It could be possible to also create like a simple template for some answers over here. All right. And just as a reminder, as I've been showing the activity wizard, of course, our very kind of common request or inspiration, we want to really empower you to create your own activities. You can do that. Just you need to learn a little bit of how Activity Wizard works. And now Activity Wizard, as you have seen, becoming easier to use. And you can modify the existing activities or customize them. And likewise, you can create your own activities from scratch. You can find activity passwords for CCNA activities in community forums on netacad.com. You will need to navigate to the communities, then to Cisco Packet Tracer forum, and then make a search for activity passwords. You will find them there. All right, let's move on to the next thing, which is the improved wireless display. And I really love how the wireless display now looks in Packet Tracer. If you can remember, before this improvement, the wireless range was shown more like a circle with a dash fill in it. Now it is more color gradient instead of this grid. Also, different colors represent different types of wireless signals. For example, this green one are mobile networks. The purple is Wi-Fi. And also, wireless range goes across containers. So, for example, in this image, we have the branch office, and we clearly can see the Wi-Fi signal goes beyond the building, right, outside of the building. These ranges only rendered and shown on the concentrator devices. They are not shown on the end devices. One quick note regarding these specific screenshots. I've taken these screenshots from some sample activities on wireless, and in these activities, custom icons are used for the physical representation, right? So these icons you see here, these are not like new Packet Tracer standard icons. They are custom icons, and you can also do something like that, of course. You can always use your graphic for icons, for backgrounds, and other stuff in PT. Packet Tracer for network automation. I've seen someone asking the question, what is PTNA? So PTNA stands for Packet Tracer for Network Automation. What it is about. Previously, PTNA was only available in the DevNet Associate VM version of Packet Tracer. It's a special version, special build of Packet Tracer, which was inside virtual machine, which was only available inside the DevNet Associate course. Now it is available, as I said, in the general Packet Tracer release. The idea here is pretty simple simulation of controller-based network management. And in order to enable that, we have implemented the network controller device in Packet Tracer. This is this, let's say, server or service or appliance represents like a network controller, which works in a way it centralizes the control over the network, and it makes devices on the network to communicate with it, and it provides configurations, it provides policies, enforces these policies on these devices, and of course also gathers all information from the network devices, operational status and things like that. And yeah, so basically it manages the whole network. And this network controller device in Packet Tracer is modeled after the DNA Center, Cisco Real Network Controller device. Of course, it's much reduced functionality, but still some look and feel more or less similar. It supports user and password management. It supports provisioning and device discovery. So this thing can actually scan the network provided the necessary input information, and discover devices and connect to these devices, kind of bring these devices into the control domain. It can also provide network assurance with providing information about the end hosts, network devices, network topology, and also the path trace feature. And it also supports some set of network-wide configuration, like QoS, AAA, DNS, NetFlow, NTP, and syslog. As you can see, these services are network-wide services, and these things can be configured from the network device. And this thing supports GUI-based configuration. So you can jump into a web browser, navigate to the IP address of this network controller, and you will see the control panel dashboard with all the controls, and you can also, click through and make all the necessary changes to your network. right? We will not go into details of the network controller in this session. There is another session which is already recorded for that. But here I wanted to point out one really interesting thing. So you see quite similar screenshots here on this slide, right? But please notice the difference. This screenshot was taken from the Packet Tracer desktop computer browser, right? So this is fake simulated browser which simulates access to the network controller. But this screenshot down below here, I took it in just a real browser on my computer, and it looks exactly the same. So yes, the GUI-based configuration and access to this network controller is now supported both from the simulated PTPC browser and also from the outside of Packet Tracer, from the real world into the simulated world of Packet Tracer and into this network device. And by the way, this feature is completely new to Packet Tracer 8. It was not available even in the special Packet Tracer built in the DevNet Associate VM. Apart from configuring this network controller using the graphical user interface, there is also a way to configure this programmatically. This network controller device supports a set of API calls to be made to it, and to gather information about the network or to apply some network configurations. And likewise, on this slide, you also see two screenshots, right? So this screenshot shows a simple network with a network controller device, and on the right side, you see this Python code, which is just basically created on a simulated computer in Packet Tracer. So this computer here, it's named Python. You can see this here as well. Here is the Python code, right? And you just can write this Python code on this simulated computer, run it, and see the result of your communication over the API with the network controller. And over here, you even can see some like 201 response code, so there is a code is working. And also, similarly to the GUI access, there is an API-based configuration available from the real PC. So you can access from the real network into the into the simulated Packet Tracer world, access network controller, and interact with it using the API. So for example, over here, I have exactly the same code from Packet Tracer copied and running in my idle Python interpreter on my real computer. The only change which is done is just changing from this simulated internal to Packet Tracer IP address to the local host with a special exposed port. And apart from these three highlight lines here, all the rest of the code is exactly the same. And you look over here, I'm getting exactly the same response from the network controller in my real Python code, right? Of course, you need to have Packet Tracer running at the time. So that's quite cool, and really impressive that kind of you can do both GUI and the API configuration both in the within the simulated world of Packet Tracer and also mix it with the real world. You have to enable the real network access, and this can be done in two ways. If you have a network controller device used in your Packet Tracer topology or file you're opening, it will ask you to enable it on the first launch if it's not enabled. So you just click yes over here. Or you can also do it like more manually. You can go to Options, Preferences, Miscellaneous, External Network Access, and enable this second box over here. And by the way, the first box is for a similar functionality, but for IoT devices. IoT devices in Packet Tracer can also access real world. Yeah, again, as I said, I will definitely not have time to go into details of what actually you can do with this network controller, which features are available there, how you configure it, your all network through the GUI interface, or even, of course, even with the API, but there was a special session on that. I did this session myself, and you can find the recording of this session in the IPD Week course. Most of this session is really demonstration, so if you find like the slide deck, there may be like 4 or 5 slides. So it's definitely worth to watch the recording of the session. Yep, you can find it in the IPD course. Good. So some other important updates: accessibility. Accessibility include a new default color scheme for high contrast support, which makes Packet Tracer easier to use for all categories of users. And also PC desktop applets adhere to high contrast theme. And overall, the tab order is improved and better overall screen reader support. That's for accessibility. And regarding miscellaneous, there are a couple like smaller enhancements. I also wanted to go over them. In the Packet Tracer settings under administration, you will find this Packet Tracer skills assessment section right now with just one register button. Why do you need that? Because sometimes you may get multiple versions of Packet Tracer installed on one computer, either intentionally, or maybe not. It's really maybe different ways. But when you launch the PTSA, or your students in the lab launch PTSA, a certain version of Packet Tracer will be used. Normally, it is the last version of Packet Tracer installed, but sometimes computer may behave a bit awkward. So this button, what it actually does, it writes all the necessary, data or information in the operating system settings to set this version of Packet Tracer you're launching as the handler for these PTSA exams. So whenever you or your student, for that matter, launches the PTSA exam, they will be using this version of Packet Tracer. In most cases, you never need this button, right? Because you just have one Packet Tracer installed, or you just have, even if you have multiple, the last installed version would normally be used for PTSA. But if things go wrong for some reason, you can click this button to fix PTSA and make it work. There is also better keyboard and mouse interactions in the rec view. IoT devices now default to wireless interface. This is important, I think. We have a bunch of IoT devices in Packet Tracer and also Internet of Things simulation. And before PT8, all IoT devices, they by default had a wired interface, so Ethernet interface to connect a cable to. You could always change that to a wireless interface, right? But by default, it was wired. Now, starting with the PT8, default is wireless, and what this will not affect any previously created Packet Tracer files, either PKT or PKS, PKT or PKA. If you already have some like IoT devices on the topology connected and maybe working in some system, there will be no change at all there, right? So they will remain with their cabled interfaces or so on. But when you add new devices from the device selection box, whatever that is, they will come with a wireless interface. So what this may affect, I think, is some scenarios, like written scenarios, when you have instructions for students, when they instruct them, hey, you need to add IoT device to the workspace, and then connect a cable. Hey, there is no cable because there is no wired interface. So these cases could be affected a little bit by these changes. Be aware about that. All right, so iOS 15 is now more default iOS in Packet Tracer, specifically regarding the 2960 switch. The 2960 switch you will grab from the switches category of the devices on the device selection board will now come with iOS 15 by default. A version of 2960 switch with iOS 12 is still available under miscellaneous menu in the same area of device selection box. Some good news for Mac users: you can now switch much easier between different windows, or you have open in Packet Tracer, like you open multiple different consoles or devices. You can switch between them using the normal system menu, I think. That's what it's called, like a dock menu. And there are also some bug fixes around IPv6. Gigabit Ethernet ports are now using MDI-X automatically. And also there is a variety of fixes to grading. I've been hearing some reports on IPv6 in IPv6 simulation potential issues some time ago. So if you have ever had any problems with that, just try again. Try to check it, and very likely it will be fixed. All right, one quick note. It's a lot of text, but I will try to kind of explain a bit shortly. What the point is here. We had, actually, it's like, this is a specific report referenced here, but I've heard similar reports a few times. The report is about the possibility for students to tamper with the Packet Tracer activity results. Student can use external computer memory manipulation tools, and there are such tools available like everywhere, to change the RAM for Packet Tracer while it is running, to alter the score, alter their grades. And in this case, they can achieve the situation when Packet Tracer shows a false grade, right, on the completion range. This score only displays on the student's computer, right? So if the file is saved and then reopened on the instructor computer, the grade will be shown correctly. This issue impacts all PKA activity files using version 7.2.0 and later, and that are currently used by instructors in assignments. Of course, in Cisco Networking Academy, we strictly prohibit cheating by students or instructors or anyone, whether or not it's technically possible. We count on our partnership with instructors to assure the validity of assessments, and we provide the following mitigation guidance for this issue. Best practices include always proctor the skills-based assessment done with Packet Tracer, whether it is done remotely or in person. For PKA assignments, always collect the final files and validate submissions separately on the instructor's computer. So basically, instead of just trusting what you see on the student's screen, I'll ask students to save the file and open the file on your computer. But I would never even being an instructor, I would never trust just looking at the student's screen, right? Because there are much simpler way to manipulate what a computer screen shows, right? For PTSA submissions, verify the quality of students' work products using the command logs and final device configuration. And never use just one vector of evidence to assess students' competencies. Sorry. Yeah, so it's best is to use combination of the following, of the listed practices. All right, cool. So we are doing well on time, more or less, and we are coming to the most exciting part of this session, I think, which is the enhanced physical mode. I have mentioned already a few changes and a few enhancements and updates, but now we will try to go deeper and in more detail. First and biggest, racking and stacking of equipment experience. What we have done, we have introduced the shelf into Packet Tracer wireline closet experience, and also pegboard. Shelf and pegboard can be used for storage. Shelf is used to store equipment, any kind of boxes, and pegboard is used to store any kind of cables. This allows us to implement the inventory system, right? Which means students are presented with just some set of equipment, sitting there on the shelf and some set of cables available to them. While equipment sitting on the shelf, it cannot be powered on and it cannot be cabled, right? In order to cable the equipment or power it on, this equipment has to be put into a correct place. And this place can be in the rack or on the table or even under the table. Now you can put some boxes under the table as well. Also, the network component box, that's what I was trying to remember a few minutes ago. This is the panel where you can select any devices and any cables when you typically build a new topology in Packet Tracer. So this box now becomes lockable, which means in the activity engine, this can be disabled and students will not be able to add any new devices or new cables or even see this panel at all. Basically, this creates the experience of they need to work with what they have, what they see in front of them. They have a set of boxes, they have a set of cables hanging on hooks on the pegboard, and that's, by the way, more or less how a pegboard looks in the real life, because for me it was a new word to learn. I didn't know that word, and it's just simply a panel with some hooks, right? It's called pegboard. Yeah, and again, the student experience is like really as close as possible to the real equipment, real lab experience. Of course, it is never the same, right? They never feel how much the box weighs. They do not like have, anyway, you understand, they never touch the metal of the device and things like that, but still it gives some better perspective compared to the previous version of the PT. So regarding the cabling, as I said, cables can be already provided to the students on the pegboard. Again, just jumping one slide back, this set of cables here is provided by the activity author. So activity author actually decides which cables are made available to students for this specific lab. Maybe if there are only a couple cables needed for this lab, there will be a couple cables, that's it. But maybe there will be a variety of cables, most of them not needed for this lab at all, and students' task is, among others, is to select a correct cable, right? Then drag and drop cabling. Now cabling should be done in a drag and drop manner, and it should be done to the port. So in the previous version of Packet Tracer, when you click anywhere on the box, like let's say on this server, I would click anywhere within the server box, it would show me a pop-up window, and I could select a port to connect my cable to. Now this is not available anymore. This can be locked as well, and students, they really must click to the specific port on the device. Right? There are still these ports are kind of they have small tooltips popping up naming the ports, but they still need to connect to the port. In order to make it more comfortable, a closer zoom was implemented in PT8. Now you can zoom pretty well. This screenshot kind of shows it. And also, of course, dangling cables. Now cables dangle between the ports when devices are connected in the physical workspace. One more thing which was added is the cable conduit, and cable conduit is used for all the cables which go outside of this wiring closer to the office space. And also, in order to connect cables to the ports on back of the devices, some devices have ports on the back, like for example this 2960 switch. We have implemented the rear view on devices. So you can rear view on the device and connect to the console port in the rear. Cable management. So as I said, when you connect cables, they hang, they dangle in between your devices in a rack, or even in what's it called, in different racks, right? Or between table and rack as well, doesn't matter. And that's how it happens in the real life. But one more thing which really happens sometimes in the real life, I will try to annotate. I don't know why annotation tool got broken somehow. I will try to annotate with WebEx and draw a little bit on the screen because it's really needed. So what happens in real life? Let's say you have this cable here, right? That's how this cable dangles. What they do in real life, let me change the color. They typically manage the cable. So they take this cable from the switch, they route this cable into the side panel, side rack stand, and then this cable goes down, probably makes some loop down there, and then pops up here and very neatly connects to the server. So in real life, that's exactly where you should see how it looks like. So that's the difference, like between just unmanaged cables, and this is how cabling and the whole rack looks when it's managed. By the way, this picture was taken from the Twitter hashtag Cable Wednesday. If you're interested about pictures like that, search social media for hashtag Cable Wednesday. We also, there is a Netacad part. The Netacad account is also a big part of that. Yeah. So, and you can do the same in Packet Tracer. Well, you can do this in Packet Tracer quite easily. First of all, you can manage individual cables. When you right-click a cable, you can just say, hey, manage this cable, and it will be managed. Likewise, you can manage by rack, or you can manage all cables in the wiring closet altogether. And here on the second screenshot down below, you see how it looks in Packet Tracer when cables are managed. You can never manage cables between table and the rack because there is no place to put the cable to, right? But all the cables which go within the rack or between the racks, they will be managed. Of course, in Packet Tracer, this is achieved in a very easy way. We just don't render these hanging cables, right? Oops, sorry, it's moving here. We just don't render these. And that kind of proves the point. The only point which it does not prove that actually you are doing with one simple click an activity which takes hours in real life, if not days. People have jobs just doing that, just turning this into this. People have full-time jobs, and they just do this really on the daily basis, right? Again, another point to prove Packet Tracer is a simulator. It never fully represents the real-life experience. All right. Yeah, yet another example of cable management. Over here, you see a little bit more populated wiring closet, and here you see different cables which are unmanaged. And by the way, I didn't mention that you can color cables as well. And when the cables are managed, the only single lonely console cable from this laptop to one of the servers is shown. And this may be a good time for a short demo session with Lab 292. I will try to very quickly demonstrate the concepts which I think I explained pretty much in well detail. Starting from the activity instructions window. As I said, you can zoom independently, topology and addressing table, and you can scroll independently, and tasks, right? So then your experience is in this lab is really, if I really would try to make this lab step by step, which we unfortunately don't have time for, I will need to basically build this topology, right? Oh, now it works, perfect. My annotation got fixed. So I will need to move equipment from my shelf to the rack and connect them to build this topology. Let me try to do that. First of all, I will need to identify the switch 1, switch 2, PCA, and PCB. And I will need to use a little bit of zoom to do that. And you see how this is, I think, the maximum. No, not yet. But I just want to show you the maximum zoom. So this is the maximum zoom. And this is switch 2. It's clearly kind of labeled here. And over here, I have somewhere, there is a spare switch which I will not need. Yeah, switch 1. I will have to zoom out a little bit to actually be able to move this stuff from the rack. I'm also using kind of bigger zoom in Packet Tracer itself just for the demo purposes. On a proper big screen, it would be easier a little bit. So I will grab this switch 1, I will put it in the rack. I will grab the switch 2, I will put it in the rack. I will grab the PCA, I will put it on the table. I will grab the PCB and I will put it under the table. How about that? I can do that, right? And next step, I will need to connect these guys together to make this topology. I will need to identify a proper cable. This is console. This is crossover. And the green one is straight through. That's the cable I will need. I will grab the cable and I will need to connect it to my computer. Again, if I click anywhere on this box, nothing happens. I really need to hover over the specific port. And of course, I can zoom in to make it a bit easier for me. So I connect it to PCA, and then it should go to switch 1, port 6. And again, I will need to zoom in a little bit closer to find port 6 over here. You see what I'm doing? And that's what students do in your lab, right? They need to find the port on the device. And this is not a trivial task quite often. So I got this connected. Now what I want to do, I want to connect PCB to another switch. I will do that again from PCB to another switch. And one thing I can actually do here, I will need to connect to port 18. I will use this inspect front feature and it opens kind of an enlarged version of the switch for me. I can even zoom it even further. So I don't have to zoom the whole workspace. I can just zoom in on the device. And then I can even connect here. I will just need to find the port 18. It's just down here. Okay. And finally, I will need to connect these guys between themselves. Port 1 to port 1. So I will use this fast Ethernet port 1 to port 1 connection, and there we go. Okay. So that's pretty much the cabling experience. And the next thing I will do, I will grab a console cable. As part of this scenario, I will connect it to COM port on the computer, and I will connect the other side to, I will go to inspect rear, I will zoom in for demo purposes, and I will connect it to the console port. Right? So look at that. Now, this console cable is connected to the console port on the back of the switch. I can flip over the switch here. Quite funny, right? Interesting. And also the link lights are active. I'm not sure how it works with the WebEx sharing, but actually the link lights are blinking right now. At least one of them. Yeah, so that's pretty much the rack and stack experience. What else can I show here? Cable management I can show, but it's very easy. So once I right click, I can manage cable, or I can manage all cables in rack, or I can manage all cables in my main wiring closet. So these are the options. Of course, in this case it's just one cable, but because others are just going between the table and the rack. So these cables are not manageable. And from here, it's pretty much straightforward. They need to go to the computer, launch the terminal, and start configuring the device with the iOS commands. So this experience is more or less as close as possible to the real life. Okay, a few more things I wanted to cover. Focus a little bit more specifically on this cable conduit. You have seen it on the demo as well. Cable conduit, again, this is a picture for your reference, how it looks in the real life. It represents cable conduit or raceway, depends on where you are, it may be called differently, outside of this wiring closet, presumably to the office, right? Uplink cables which go out from devices, they hang to the conduit, so they go to conduit and they also hang. And also this also works with patch panels. So if you have a patch panel here, you can also connect the back of the patch panel to the conduit to really represent the structured cabling in your network. And speaking of structured cabling, just a reminder, this is not new in Packet Tracer 8. It was available even before, but it greatly enhances the physical experience. In Packet Tracer, you can use patch panels for copper and for fiber, and you can also use wall mounts or sockets for, again, for copper and for fiber. Cables connect to the back of these devices, which are these punch-down ports. This represents the structured cabling. This is basically these are cables that sit inside your walls in raceways, and they're part of your building, right? And cables which connect on the front to these jack ports, they are patch cabling. This is the piece of cable you plug into a socket in the wall, and another end of this cable you plug in into your laptop. And or you can, that's what happens kind of on the